All right, so today we're going to talk about kind of going backwards from what we've been doing. So we've been starting with a polynomial and then solving down to solutions or zeros or roots or x-intercepts. Now we want to take those zeros, those roots, those solutions, those x-intercepts, and create the polynomial. And if we can continue to make this connection between solutions and factors, then it's going to make our lives a whole lot easier, right? So the point of today is, again, to be able to take these solutions, these zeros, and create polynomials. Before we do, we want to make sure that we can handle both real and imaginary solutions, right? We know we're going to have imaginary solutions because not every degree 4 polynomial will hit the x-axis 4 times, as it should. It should have 4 solutions, 4 x-intercepts, but sometimes that doesn't happen, and that's where our imaginary solutions come into play. So to help remind what we do with imaginary numbers when we're multiplying, because if we are using factors to get back to a polynomial, that means we're going to be multiplying some stuff. We have a couple of review problems here. Go ahead and double distribute these out and simplify down, and we'll see what you come up with. So as you remember, we double distribute here. 3 times 4 is 12. 3 times negative I is negative 3i. And then we distribute here, we get 2i times 4 is 8i. And 2i times negative I is negative 2i squared. We can combine like terms here and here and get 12 plus 5i, but you have to remember that I squared is negative 1. So we can take negative 1 times negative 2 and get positive 2, and then combine these guys and get 14 plus 5i. Okay? Same thing over here. Double distribute 1 minus 2i, and then here plus 2i minus 4i squared. Now something a little bit more interesting happens here, in that these two like terms add out to 0. This guy still again is negative 1, so we take negative 4 times negative 1 and we get 1 plus 4, which is 5. So it is entirely possible that two complex numbers can multiply out to give you a real number. Okay, but the I squared, it seems to be what gives students the biggest fits. We got to make sure that we understand that's negative 1, and we can just multiply it to its coefficient. Okay, now if we can do that, then we can create any polynomial that we are faced with if we're given the roots, the zeros, the solutions. As long as we understand that where this solution of negative 3 came from, right? So go back to imagine if we had the polynomial function. The way we got that negative 3 is that we factored down that polynomial, and because of the zero product property, we set that factor equal to 0. And then we solved, and we got x equals negative 3. Well, in order to see that it was set equal to 0, we'd have to add 3 to both sides. So we get x plus 3 equals 0. Well, look here. X plus 3 gave me a solution of negative 3. It's kind of like taking a factor for a polynomial and trying to use that factor in synthetic division. Remember, we changed the sign of the constant in that binomial to put in that tiny box? It's the same thing here. We're going to switch signs to create our factors. All of that basically means that to create our polynomial, if one of our solutions was negative 3, that means our factor had to be x plus 3. If one of our solutions was positive 5, that means that one of our factors had to be x minus 5. Switching signs. If one of our solutions was positive 2i, that means that one of our factors was x minus 2i. And if one of our solutions was negative 2i, that means one of our factors had to be x plus 2i. So those are all of our factors. And again, factors are things that are multiplied together to get you back to something else, right? So what that means is we want to go ahead and multiply these guys out. Double distribute. Now, you're going to want to multiply the imaginaries together and multiply the reals together separately, and then multiply whatever you have left. Okay, your life's going to be a little bit easier. So we're going to double distribute here, x squared minus 5x, and then here get plus 3x minus 15. And then we're going to double distribute here, get x squared plus 2ix, and multiply here and get minus 2ix minus 4i squared. A little bit weird, 2ix, but that's what happens. You've got an I and an x. You just write them down next to each other, right? Now, simplify by combining like terms. X squared, negative 2x minus 15 here, when you combine those guys. And then here, you combine these two like terms, but 2ix and negative 2ix will give you 0, right? And then again, remembering that I squared is negative 1. Negative 4 times negative 1 is going to give you positive 4. So that's where the positive 4 comes from. Okay? Now, we're down to these two factors, so we want to go ahead and double distribute again. Distribute through by the x squared, so you get x to the 4th minus 2x to the 3rd minus 15x squared, and then through by the 4. Plus 4x squared minus 8x minus 60. And then to simplify this out, we want to combine all our like terms. There are some here. So x to the 4th minus 2x to the 3rd minus 11x squared minus 8x minus 60. And there is our polynomial. Okay? And it's that easy. I mean, it should be easy. Hopefully you find that to be easy to multiply those guys together. It's just going to take a little bit of work. Okay? All right, another one here. Again, just re-emphasizing that if I want to write the function f of x equals, so if this is a solution, that means it came from a factor of x plus 2. If 3i is a solution, then that came from a factor of x minus 3i. And if negative 3i was a solution, it's going to come from x plus 3i. I'm going to multiply the two imaginary factors together first, because that's going to simplify down pretty nice. Distribute through, and you get x squared plus 3ix, and then through here, minus 3ix, and then minus 9i squared. Your like terms here and here are going to add out to 0. You get x squared. And then this is negative 1. Negative 1 times negative 9 is plus 9. Double distribute here. You get x to the 3rd plus 9x. Double distribute there. You get 2x squared plus 18. And then a little math OCD kicks in. We want to make sure that we write these guys in order. X to the 3rd plus 2x squared plus 9x plus 18, and we are done. Okay? All right. Now it's your turn. You've got these guys here. Go ahead and stop the video, write out your factors, double distribute them out, combine everything, and then start the video back up, and you can check out the solution. Okay? Okay, so did you get x to the 4th plus 7x to the 3rd minus 17x squared plus 7x minus 18? Okay, if not, go through the work here. When you distribute the x plus, first of all, what are your factors? X plus 9, x minus 2, x minus I, x plus I. And then when you distributed the x plus 9 times the x minus 2, you should have gotten x squared plus 7x minus 18. Now, when you double distribute the x minus I and the x plus I, something weird kind of happens here you got to be careful about. Of course, the negative ix and positive ix are going to add to 0. But here, the negative I squared. Now, I squared is negative 1. So this would give you a negative 1, which of course would become a plus. So you got to be careful there. Make that an x squared plus 1. Then you can kind of see through how the rest of the distributing works. Okay? Hopefully that makes sense. If not, make sure you come in and get some help, and we'll figure it out, right? Now, to apply this idea, right, We got a couple of story problems here. Andrew is building a sandbox for his cousin Evelyn. He wants the box to be 6 feet longer than it is wide, and its depth. Sorry, something weird happened there. So, story problem here. Andrew's building a sandbox for his cousin Evelyn. He wants the box to be 6 feet longer than it is wide, and its depth to be 2 feet less than the width. So write the equation that gives the volume of the sandbox as a function of the width. And what it means as a function of the width is that whatever variable we're using should stand for the width. Well, we're going to let that be x. We don't know the width. Right? So this is going to be x. Now, if the width is x and the length we want the length to be 6 feet longer, then we're going to go x plus 6. And the depth to be 2 feet shorter, or 2 feet less, we go x minus 2. And of course, the volume as a function of the width is going to be length times width times height. So x times x minus 2 times x plus 6. Distribute the x, we get x squared minus 2x. Now we're ready to double distribute here. X to the third plus 6x squared minus 2x squared minus 12x. Like terms here, x to the third plus 4x squared minus 12x. Okay? And that's your volume as a function of the width. Now, the next box in your notes, the next slide, would say that we want the sandbox to hold 48 cubic feet of sand, right? We want the volume to be 48 cubic feet. Well, I'll keep the same slide so we can see where everything's coming from. Basically, that means we're going to take our volume function and set it equal to 48. And now we want solutions. Now we want values of x that would make that equation true. Well, to find solutions, we want to get this equal to 0 by subtracting 48 from both sides. And now we're back to your previous homework, right? Where we have several options of trying to solve this polynomial, to find the solutions, right? One thing we can do is factor by grouping, and this guy hopefully will factor by grouping. GCF here, we take out an x squared, and we get x plus 4. GCF here, we take out a negative 12, and we get x plus 4. Now your factors become whatever's on the outside of the parentheses times whatever's on the inside. Now, we'd want to try to keep factoring, but we can't factor that, guys, so we can go ahead and take our factors and set them equal to 0 to find out how to make them zeros. So we get negative 4 here, add 12, square root both sides, and immediately we put in our plus or minus. So plus or minus the square root of 12. Now think about this. There's context to this, right? I know that the width can't be negative 4 feet, and it also can't be negative square root of 12, only because the width can't be negative. So that leaves me with the positive square root of 12, and that's fine, but I'm not going to walk into Home Depot and ask for wood that's the square root of 12 feet long. Okay, what I'm going to do is walk in and say, hey, I want 3.46 feet of wood, right? That's what the square root of 12 is. So 3.46 feet is what we're going to use for the width. Okay? Now, it's asking for the dimensions. And so what we would do at this point is go ahead and plug in the 3.46 for x everywhere. So the width would be 3.46. The depth would be 1.46 feet. And the length would be 9.46 feet. Okay? Don't forget to plug it in. And there you go. Now, I think things are wigging out right now, so I'm going to stop the video here. I know you got one more example in there, but hopefully that helps you get you through your notes. And if you need one more example, come on in and see me, and we'll take care of it. Okay? Homework's out in Canvas. Make sure you get that done.